Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics that every civil engineer should know. That is, what is development length and what is the lap length and what is the application area and what is the purpose and what how to calculate each and everything in this video I will discuss. So stay tuned until the end to get the full information about the development length and the lap length. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting our time, let's jump into the subject, development length and the lap length. First, we need to know what is development length. That is, what is the definition of development length? Development length, LD, is the length of the reinforcement bar required to embedded or anchored in a concrete to develop its full strength and ensure that the bar does not slip out of the concrete. That means that is a development length is anchored or the embedded inside the concrete, and it is defined as the LD. Let's see from the example here. Here it is a beam column junction. Okay, in beam column junction, this is the beam and this is the column. In the beam column junction, beam reinforcement is embedded inside the column. Now whenever it is embedded inside the column, the length required inside the B column, the beam reinforcement, that is the development length or the embedded length. So from this, from whenever it is entering into the column, from this point, the what is the minimum requirement, we will understand how to calculate that one in the later. So what will be the length of this, that we will calculate, but the length required to embedded or anchored this structure to in this structure, that is the development length. So again, is the reinforcement bar required to be embedded or anchored in concrete to develop its full strength to ensure that the bar does not slip out of the concrete. So if this is not given properly, that means whatever the length is required is not given properly, there will be slippage or there will be a structural disintegrity, so the lifespan will not be achieved whatever as per our requirement, so there will be a structural failure. So these are the called the development length. So is development length, by definition, it is transferring from one structure to another structure. Here it is from beam to column. So it is the fundamental things for the development lane, that it is transferring the load from one structure to another structure or one member to another member. Here it is from beam to column. Now we need to know what is lap length. Lap length, by definition, what is that? Is lap length is the length provided to overlap two rivers to safely transfer load from one bar to another, ensuring continuity of the reinforcement bar. Now, here it is, that means it is transferring the load from one bar to another bar. Why? See, the standard length is B 20 or 12 meter of the bar. नाउ हमारा अगर स्ट्रक्चर 12 मीटर में ज्यादा है, जो कि नॉर्मली होता है, सो क्या करना पड़ता है, एक बार से और एक बार को लैप करना पड़ता है और ओवरलैप, दैट ओवरलैप इज कॉल्ड द लैप लेंथ. सो इट इज ट्रांसफरिंग लोड फ्रॉम वन bar to another bar in order to provide the desired length of the structure if it is more than 12 meter or the 20 meter, 30 meter, whatever. So the lap length is become the length of the overlap of the two bar to transfer load from one point to another point. Now, the definition of the what are the development length, that is load transform from one structure to another, one member to another member to embed or transfer the load safely. Here is load is transferring from one bar to another bar. Let's see what is the purpose. Purpose is that for development length, ensuring that the river can develop its full strength without slipping out of the concrete. So this is the anchorage from one member to another member. If it is not properly anchored, it will happen, it will slip it out. So it is the anchorage length or the development length. So it is in the junction of the two member, beam column member, pile cap member, or this whenever column is coming to the foundation, that all the junction of the two different member of the structure is development length is provided. And here it is provided a continuous path to transfer the loads between two overlapping rivers. That means it is become a continuous path to transfer load from one bar to another bar. That is called the lap length purpose. Now, let's see the next topic is what is the application that already we discussed. See, used where the bar ends within the concrete and needs to anchor securely. See, already discussed. That means when a beam is coming to the column, that means beam is ending and the column is starting. So one member is end, another member is starting. Now the load from beam to column to transfer for the structural integrity. Now what for these transfer of the beam load, how much length is required of these rebar is called the overlength. So whenever a member is ending and it is transferring to the other member, the development length is providing. Beam column junction. Say this also whenever a primary beam or the secondary beam, when a secondary beam is coming to the primary beam, the development length or required, because this secondary beam is ending at the primary beam and is transferring the load to the primary beam. And then column, whenever resting on the foundation, the development length is required. In the pile cap also, we need to, whenever the pile cap or it's coming, this pile also need the development length, or the pile cap from the pile cap or the column or the pier is coming, that is also the development length is required. So two different member and one member transferring to load to another member, that area is development length is coming, and used where two rebars need to be joined or spliced together to form a continuous reinforcement. So here it is the lap length to required for the joint of the two rebar to transfer the load smoothly from one bar to another bar. The next point is what we'll check, that is application area, that I already discussed. That is the end of structural management or the lap and splices zone. Now here it is a catch. So what is the lap and splices zone? We say the lap development length is when the member is ending and it is transferring to the another member the load, whatever the length required, that is the development length. Now then the lap and splices zone from one bar to another bar. Now the question is, can I make lap or the splices is anywhere in the structure? The answer is no. We need to find out the lap or the splices zone of any structure, and only on the lap or the splices zone we can provide the lap. Now, what is the lap and splices zone? That is the splices zone where load can be transferred without harming the structural integrity of that. Now, how can I find out the lap or splices zone? There are several things we need to understand. First, what is the member and what is the geometry on the member and what is the load pattern? Suppose if it is a beam, then what type of beam it is, whether it is a continuous beam, simply supported beam, cantilever beam, fixed end beam, and how the load is coming onto that. This is a uniformly distributed load or the point load, and how the other element, that means primary, secondary beam, beam column junction. So according to that, we need to find out the compression zone and the tension zone. And according to that, where the bending moment is 0 or bending moment is less, on that area only we can splices or lap the two rebars. So for the lap or the splices, we need to first find out the lap zone or the splices zone. And according to the lap zone or the splices zone only, we can place the lap or we can overlap two bar. And this is the main things we need to know about the lap or splices zone. And already discussed what is the development length, that is the end of structural element. Now, the last part is that we need to what is the deciding factor. Here it is a dia of bar, design strength of rebar, and grade of concrete is deciding factor whenever we are calculating the development length. How we can calculate? See, here is the development of the rebar formula is in clause 26.2.1 of IS 456. It is given that LD is equal to phi sigma s 4 tau BD, where phi is the nominal diameter of the bar, sigma is the stress of bar at the section considered a design load. Phi, suppose it is a 20 mm bar, so it will be the 20, and sigma is the stresses in the rebar, the design. That means if it is a grade of concrete, sorry, grade of steel is 415, 500 or 550, whatever it is, the sigma is that. And tau BD, design bond strength, that is depend upon the grade of the concrete. It is also given in the 26.2.1. But how to calculate the development length? I made a detailed video on that. please check link in the here or in the description. You will get full details about how to calculate the development length, how to calculate the bond strength, how to calculate the development length in tension or in the compression. That everything I discussed, please check that one. So from these formula we can find out the development length. Now what is the deciding factor for lap length or splices? That's all same of the diameter of the bar, design strength of rebar, get drop concrete, and also the loading pattern. That means how the load is coming on the structure, and accordingly we'll to find out the lap zone and the splices zone. But in the IS 456 26.2.51 in clause, it has given all the details how we can determine the lap or splices, and the lap splices shall not be used, where we can not use the lap or splices, and what will be the minimum diameter of the lap, and what is the lap will be whenever two different dia of overlapping, suppose is 20 mm and 25 mm, it is overlapping each other, then what will be the lap length for that? That is also then lap length in compression. So let's check one by one. Lap splices shall not be used for bar larger than 36 mm. Now it is given one constraint that if it is more than 36 mm, we cannot use the lap or the splices. Then what will happen in case where welding is not applicable, lapping or reverse larger than 36 may be permitted. So maybe that means there is a code, in which case additional spiral should be provided around the lapped bar. Now to avoid this, we are using the mechanical coupler. So what is mechanical coupler? It's a mechanical device to join these two rebar or splices the two rebar. So what is mechanical coupler and what is the properties? I made a detailed video on that. Please check in there or in the description. You will get full information about the mechanical splices of the reinforcement. So here first is lap splices not be used more than 36 mm. Now lap splices shall be considered as staggered or if the center to center distance of the splices is not less than 1.3 times of the lap length calculated. So lap splices should be staggered. What does it mean? That means in a single section, we cannot provide lap all the bar in a single time. That means if I have the 4 bar in a beam section in the bottom, we cannot splice 4 bar in a same section. We need to stagger that. And what is the staggered diameter? That is not less than 1.3 times. So that we need to mention that the lap or splices should be staggered and it should be minimum 1.3 times, but that is also should be in the splices zone itself. Then again, it says lap length, including anchorage value of hooks of our bars in flexure tension, shall be LD or 30F5, whichever is greater. And for direct tension, shall be 2 LD or for 35, whichever is greater. So here it is saying we need to first find to calculate the LD, that means the development length. Then we need to find out if it is a flexure tension. Then 35, if it is 20, that means 30 into 2600, and whatever value we'll get from LD, that whichever is higher, that has to mention. So the straight length of the lap shall not be less than 15.5 or 200 mm. That means it should be no way 200 mm less. Top of a section as cast and the minimum cover is less than twice the diameter of the lap bar, then the lap shall be increased by a factor of 1.5. That is also another criteria. Another criteria is key corner of the section of a minimum cover to either face is less than twice the diameter of the lapped bar, where the clear distance between adjacent laps is less than 75 or 6 times the diameter of lapped bar, whichever is greater. So that also we need to consider. Now, what is the splices in tension member shall be enclosed. The lap length in compression shall be equal to the development length. Now, it is saying clearly and directly that lap length in compression is will be directly to the development length in compression, calculated as described 26, but not less than for 24 by. So, if the development length is become less than 24.5, suppose it is a 20 mm, so 24.5 is 480. So, if the development length is less than 450, we are not use. We need to use the 480 mm. And but if it is 480 more than 480, then we need to use the same lap development length. When bar of two different diameters are to be spliced, the lap length should be calculated on the basis of diameter of the smaller bar. That means here whenever it is a 20 mm bar, another is 25 and 20 splicing each other. Now, suppose we have the 50D, we need to the splices length or the lap length. Now, 50D is for the 20 is 1250 and for the 20 is 1000. So which one has to follow? The smaller bar, that means 1000, that is 50D and 50 into 20. That is smaller the bar we need to follow. Then when splices welded fabric is to be carried out, lap splices of wire shall be made overlap, measured it between the extreme crosswire shall not be less than spacing of crosswire plus 100 So this is the splices. So these are the thing about the splices of the rebar. We need to ensure whenever we are splicing two bar in a section, and also we need to find out the development length as discussed into the clause of IS 456, and accordingly we need to provide the development length. So in summary, development length is the anchorage length when our two structure is meeting and when structure is ending and transferring the load to the other member, and the lap or splices to transfer the load from one bar to another bar. And everything in details I have discussed, and I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comment so that from your valuable comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.